Hello everyone, welcome back to the channel. Today we are diving into a powerful tool for environmental monitoring, Google Earth Engine. Uh, Especially we are discussing about flood water extent analysis uh, using the Google Earth Engine and MODIS satellite imagery. And here we are using technique that is called modified normalized difference water index. So if you are a student, you are a researcher, you are a development professional, or you are curious about the remote sensing analysis, this video is for you. So uh, for the analysis, let's go to the code section. So my prior assumption is like that. Uh, those who are watching this video, you have a minimum understanding about the Google Earth Engine and how Google Earth Engine works. So I am not going to discussing that part. So for flood extent analysis, for any kind of analysis, we need a study area. So uh, for the study purpose, we took a study area in the north eastern part of Bangladesh, especially the where flash flood is occur every year, the Haur area, so that our study is more close to the real scenario. So for make this video short, like an other video, our code is ready. So we are going to more discussion about the output and the code, so that I make this video short for you. Okay, this code is ready for you, and I am sharing the whole code in the video description box, so that you could get easily the code, so you don't bother about the code. Okay, for the study area we called a variable, that is AOI. You have seen that the for the NDB analysis we using the assets, uh, using administrative area from our already uploaded assets. But this video we using the feature collection already stored by the Google Earth Engine, that is the how global administrative uh, unit layers, and level 2 we are using, and in Bangladesh perspective the level 2 is the district level. Here we filter the study area at the administration level 2, and name is the Sunamganj, that is the northeastern district, there Sunamganj. Uh, for visible map at the center level, we call the map center object, and using AOI and its level 9 to more visible at the study area level. And we add map to the display, where we color is blue and name it as study area. So let's run the code, and we have seen that our study is visible to the map window. In the second section, we load MODIS water mask. So MODIS water mask is the already extracted image from the analysis, that is the permanent water body. So uh, uh, the like the river, lake, or Haur area where water is permanently stored, so that so on a stage we collect the permanent water bodies. Secondly, we call the MODIS image, and using image we analyzes the modified normalized water index, and we get the water extent area. So firstly we get the permanent water area, and we get the water extent area. So from the water extent area we subtracted the permanent water area, then we get the flood affected area. So For the water mask area, we using the uh, MODIS water mask collection. That is the line, that is the command for the collection, and our variable is water mask collection. And we filter boundary with our study area, and the we want the image for the short nearest time from now when we run this code. So, and secondly, we call another variable, that is the water mask. So where we call the water mask collection, and we use the first image, and where we call the variable that is the water mask uh, in called water must select the band showing the water. So in this collection there are some other bands, but the water mask, this collection is showing the permanent water body area, and that is the clip by our study area. So finally we add the layer of water mask and named it the permanent water for the MODIS images, and we give the code for the color is the our color is mostly blue, so that our color is the for the permanent water color, that is the blue. So uh, we may change the color, okay, so that does not make any uh, conflict with our study area. Okay, you have seen that the permanent water we get, that is the one kind of the violet color. So we get the permanent water body area. So when we get the permanent water body area, after that we are collecting the MODIS images and then put the analysis for the water extent. Okay, let's see, the here is the load for MODIS surface reflectance collection for the pillar period. So we call the variable that is MODIS. That is the MODIS image collection, and this is the MODIS image collection path and the filter date for the July 1st week, and filter boundary with the AOI. This is the modified normalized difference water index function. So we call the function name is add mndwi, and we put image as input. So in the from the image uh, we get the green uh, band, that is the surface reflectance band 4 in the MODIS image, and the shortwave infrared band, that is the surface reflectance shortwave infrared. So and another variable called is the normalized difference water index, modified normalized difference water index. So here the green subtracted by shortwave infrared, and it is divided by green plus shortwave infrared. So let's search about the function. You make clear about. Okay. Uh, okay. In the Google, you have see the function. Okay. And that is the modified normalized difference water index. It is a spectral index for the water extract feature from the satellite imagery. Uh, okay, you have seen that we utilizing green and shortwave infrared band and differentiate water body effectively for build-up area. So here is the equation is the green band subtracted by the shortwave infrared band, and that is divided by green band and add the shortwave infrared band, and rename the band is normal modified normalized difference order index, and finally return the image and add band as a modified normalized differentiate order index. So we call the function, still we are not call our images. uh, let's call the put the function in the function imply the images. Okay, let's see. We called another variable, that is the flood out variable, and here you have seen that uh, we map the function to the MODIS uh, output. That is the, you have seen that this is the MODIS image collection, and we map out the function, that is the add uh, modified normalized differentiate order index MNDWI, and we call the median, that is the help us to reduction the uh, a single composite reduction the single image, like create a single composite image by taking pixel-wise median across all days. This is especially useful for the reduced cloud effects. So you know that in the monsoon season, that is the serious issue, that is the cloud effect on the images. So uh, we always try to collect image after the when the cloud is very less, but that is the another problem is that you don't get the water, because this is the fallacy region, so water didn't stay for the long term, but we try to use the median function, that's why the reduce the cloud effect, and as well as clip with the study area, and we add the map, we add the flood to the layer. So you have select that we use the MNDWI. This is the MNDWI where we rename our output band. So we call our output band MNDWI and put function minimum on and maximum, minimum minus 1, maximum plus 1, and it is white to blue band, and called it MNDWI June 1st week 2025. Let's run the code. Okay, we answered the study area, then it is easy to understand for both output. Okay, okay, we have seen that this is the permanent state area, and we get the normalized, uh, modified normalized difference order index. So we put the threshold to this order index, and finally put our water body, water extent area. So you have seen that we call three variable, that is flood water. So yeah, we get the image to our study area, and we got the permanent water body. Now we try to find out the flood water extent area. So in the flood affected area, we select the band modified normalized difference order index, and we put the threshold value 0.05, only the pixel on MNDWI, because that is our previous output. So this is the common indicator for the water presence in MODIS image. So that now we get the flood water affected area, and additionally we get the permanent water body, and from the water mask uh, where I use the create a binary image. So in the binary image, in the image on, that means permanent order, and 0 means others, or nothing is happening there, like that could be the um, settlement or anything. So this is the permanent order and this is the filler order. So what is the filler only? So that the primary concept is that the permanent outer body is not flood affected area. So those area who is the affected by the what uh, affected by the flash flood, that is our main target. So in the flood only area we uh, pick the flood water affected area and subtracted by the uh, permanent water area. So uh, this is our flood only affected area. So you have seen that we get the flood affected only area. Uh, okay, now I going to visualize the matter so that you could easily understood the output. Okay, let's run the code. Okay, one thing I could do, that is the we don't need a style area for the, let's run the code. Okay, you have seen that already we get two images. Okay, that is okay. You have seen that this is the 4 output. So just let me answer and explain. Okay, this is our permanent water area, that is the collected from MODIS water mask, and second is that this is the normalized differentiate water index, that is the MNDWI on the first quarter of the image, and second the detected water detects the water is detected by um, from the mask, and finally the water extent area. You have that the area we detected as a water presence, but our affected area is less than that because we subtracted with the permanent affected area. So this is our output that we want to get, and here are additional thing, that is the uh, we want to know that the area was affected by flood, because the policymaker or the higher officials mostly they want to know the area get affected. They don't bother about the uh, the code behind this or bother about how we assess this. But end of the day, they want to know the area affected by flood, because they go for action, they do for something. So for flood affected area assessment, we call the flood only, that is the flood rate. Okay, we use the reducer region and use the geometry, and scale is 500 because uh, one thing I don't share with you, that is the image we are using, that's resolution. So here we are using uh, the very low resolution MODIS image, that is resolution is 500 meter to 500 meter or half kilometer to half kilometer. So this is very long distance and the image resolution is very low. But in the larger scale flood, this gives you a level of insights. So I print the flood area and in a square kilometer. Okay, that is our flood affected area is computing. Okay, you have seen that the uh, July 1st week, the Sunamganj area is flooded around 1000 square kilometer. So this is the way we are uh, assessment, and this is the output we get. So you could apply different area for this assessment, like we use the change the name of the district, like APNI, use the say that just change the name of the district and run the code, and probably you get the output. So okay, you have seen that the lots of area is affected by flood. So mostly you have think about the threshold value you put for the flood effect or water effect area calculation. That is important because mostly we use 30% threshold or zero point 0.3 sometime to get the flood affected area. Uh, but for the horizon, the area is flooded frequently is here. Yeah. So you have seen that since the value to 0.15 to 0.3, the flood affected is 0. So if you change it to 0.2, you have seen that you get some area that is already flooded. So yeah, really, this really important to think about what you really want to get and how the output is assessed. So this section is important. So to understanding about the locality or the flood pattern, this threshold value is changing sometime. So you should think about that, and you have see that this is the final output of our study. The flood affected area is the Feni and the first quarter of the July. So thank you all. This is the end of today's video. So you may have some question. I understand that if you have some question, please put in the comments box. I add the code in the description box so that you don't face any challenges. Again, thank you all. If you feel that this video may help you uh, to understand or clarify something or uh, help to the people, if you feel comfortable, let's subscribe this channel. So thank you again. Thank you all.